Hello. I don't know if people can see me. Maybe they can. Welcome to panel discussion here for Robotics X Tokyo, which is our meetup group. Tonight we're talking about robotics in education, and obviously we have a robot here. We have a great lineup of panelists, and I'd just like to take you through first just a very quick introduction to our group. So who we are a meetup group that exists. We connect robotics professionals, hobbyists, and generally interested in robotics people in the Tokyo area. I had done something like this back in Silicon Valley called Silicon Valley Robotics, svrobo.org. We want to bring together companies and individuals for the purposes of networking and communication, collaboration, hiring within the bounds of IP protection, because that's a sensitive area. And then we strive to inspire the next generation of roboticists by promoting a healthy, diverse, and respectful community full of passionate future leaders. And we have started as a meetup group, but we're growing rapidly. As you can see, we have 264 members as of about an hour ago. The organizers are Marco, myself, and Timothy, who couldn't be here tonight. We are at different robotics companies, but we come together with the singular goal of bringing together all robotics companies in Japan, in Tokyo. Okay. And then our speakers tonight, you can see here, they're going to give a quick self-intro. So very quickly, we have Yuko Igawa and Hiroshiyuki Ishii from Dr. Tech, Megumi Ishikawa and Tamanegi-san from Groove X, Lovat. And then we have Nicholas Tankard, and he's representing Singularity Battle Hub competition. And then finally, we have Abi Hamed, who's our moderator, and he is with Tokyo Coding Club. Okay. So this is our agenda. We're going to do quick 5-minute introductions or less if possible. 30-minute panel discussion, give or take, around some question prompts, and then we'll leave 10 minutes for audience Q&A at the end. And then we're going to follow it by networking, socializing, and refreshments outside as we do at the Thursday gathering. Okay, so take it away.
Okay, thank you very much, Michael. First of all, I'm very honored to be here. Thank you very much for the great opportunity. And my name is Yuki Igawa. I'm a founder of Dr. Tech, and I was born in a Fukuoka prefecture that is very far from Tokyo, and I worked as a high school teacher for about 10 years. And then I moved on to the career in finance. So I worked at banks, securities firms, insurance companies, and asset management company. And then as gaining an extensive career at IT company, I founded Dr. Tech in 2020, just 3 years. And so our Dr. Tech runs a school for kids and with a D-Tech education method. That is a combination of English, programming logic, and financial literacy for children aged 4 to 10 years old. And now we have 40 or 50, more than 50 students here. And also now we are planning to start a new learning course about robotics in May and yes, in 2023. Yes, thank you very much.
Okay, my name is Hiroyuki Ishii, and I'm also, working for Dr. Tech now as a more like a technical advisor type of job, and then I've been working for software engineering type of job, and yeah, my main interest is like teaching programming using robotics, so that that's basically Dr. Tech is going to trying to do. And today I really happy to join this, and then want to learn how robotics is helping education, or how it's used in education area. Yeah, thank you.
Sorry. Okay. Hello, everyone. My name is Megumi Ishikawa. I'm in charge of product management of robot software.
Today, I'm glad to share our challenge and discuss this topic with you. First, I will introduce a product, Robot, and our company Group X. Robot is here. I'm live with them, and their name is Tamanegi, which means onion in Japanese. Robot has no gender, so I use they for robot. They are robot-like pets, little sisters and brothers and friends. Please, next. And the product name comes from lab and robot, often misspelled as labot, but it's labot. Lab is what we want to deliver. So, and Group X is a startup company in Tokyo. Labot is our only product. Our goal is improve well-being of people through robotics. And the founder and CEO of Group X is Kaname Hayashi. He worked at car manufacturer for a long time, and after that, he worked for Pepper, a famous humanoid robot. About 8 years ago, he founded Group X. And then, why did we create robot? Here is a definition of robot taken from Wikipedia. Robots do some tasks on behalf of people. Especially, robots have enabled mass production. It makes our lives convenient, but has that made us happier? This is the issue we raise. Here is a new definition of robot. Thank you. Now robot does not perform tasks, but stay with you. We want to make a new robot being that needs to be taken care of, not taken care of you. We believe robot could make people happier. The problem we want to solve is distress for loneliness. Isolation and loneliness are significant issue in today's society. As a solution, we focused on animal therapy. In particular, we refer to how people and dogs form bonds, because dogs are one of few animals that can create a strong bond with people. Studies of relationship building between humans and dogs show that eye contact and skinship are essential. We don't need to imitate the shape of animals to do these two things. We thought about how we could create this experience with a robot. We defined several experiences required for robot. Robots' most basic actions are to move to who they love and prefer to be hugged and stroked. We need to create this experience as natural and comfortable for people. Robot is designed to realize these experiences. Robot has rich CPU resources to recognize people and spaces. Robot also has a comfortable form that makes you want to hug them, smooth and soft textures, and almost the same body temperature as humans. Robot is equipped with more than 50 sensors, SLAM technology, and many other points that I would like to introduce, but I don't have time today. Oh, sorry. Okay. It has been 3 years since we launched Robot, so let me explain current situation. Over 10,000 robots are running, which is the number of active devices. Robot is available only in Japan. We will continue to do our best to bring Robot to many people. Thank you for listening. I will talk about example in education at panel discussion. Thank you.
Thank you. So hello, everyone. My name is Nick, and I'm a robotics and software engineer from Australia. I've worked in a couple of different industries, mining, defense and aerospace, and now most recently automotive, here in Japan. Back when I was in university, I did a lot of volunteer work with organizations like RoboGirls and RoboQuest, groups that work to try to get underrepresented groups more into engineering, inspire the next generation of engineers. And since joining industry, I've continued to work as a company representative supporting these groups, both in Australia and here in Japan. This year, I'm helping out with a group called Singularity Battle Quest, specifically their RoboQuest. We're designing a robotics competition for students to compete in from across Japan. We're actually doing the finals run of that this weekend. So good luck to all the students with that. And yeah, I've been supporting in that respect. Thank you very much for having me here.
Hi, thank you very much for the introduction. I will introduce myself just very quickly as well. I'm a robotics engineer from the UK, and I've been in Japan for about 10 years now. Previously to coming here, I was doing some research in robotics and decided that I wanted to pursue a career in the area. But at the same time, I've also been quite interested in education since I was quite young. So did a lot of teaching back home. And then when I got here and started my career in Japan, I realized that there was an opportunity for me to continue educating children here in Japan as well. But moreover, I wanted to try and focus on the application of robotics in their education, since I think that there's quite a good, well, there's always been a strong culture of interest in robotics anyway in Japan, of course, part of the reason we came here. So I've been working with this company called Tokyo Coding Club for about 5 years now. And since we started, our main emphasis was to try and encourage children to think about technology in a creative and imaginative way. And we do try to apply lots of different types of robot technology that children can interact with at a young age, that should inspire them to get into the subject more as they grow older. So yeah, I hope to do a good job at this today, and thank you for the opportunity. Right, okay, so our first topic for today will be robotics in education. And the question is, what are examples of robots being used in education inside or outside of the classroom? Okay, so anyone like to venture?
Yeah, maybe I can jump in quickly on that one. So I see robotics used quite a lot as a way to get the first introduction of engineering into students. I tend to find that when kids work with robots, they get very engaged and very interested in them very quickly, in a way that's like something like programming can be a bit more tricky to get their initial interest there. So I think it's a really good entry point into engineering as a whole, programming as a whole, and of course, robotics specifically.
Right, yeah. At the school that we teach as well, like I said, we try to encourage the children to use lots of different types of robotic technology to inspire them to get comfortable with that type of format. Some of the things we've used, for example, in the past aren't really on the level of Lobot, unfortunately, but you know, we try to think of ways that would allow their creativity to think of robots in this way, as well as, you know, the more traditional sense of you know, robotics, which are like in factories or in you know, in house cleaning up and that kind of thing. So yeah, we've done quite well with that. Have you guys ever seen anything like that in your company so far?
Actually, I'm not sure, but I have no idea about this question, because we are just trying to find the good education, how to say, problem from now on. So maybe you have an idea. You have already, right? Your company have already used tamanegi.
Yes. Okay. I can introduce two examples in classroom and at home. Okay. You can show the formats, right? Okay, thank you. Yes, we conducted a demonstration experiment project with an elementary school in Tokyo 2020. I can introduce this case. Robots were installed in classroom at each grade level, and students spent time together. Um, and at the beginning of the experiment, our company staff introduced robot to the students, and each class named their robot like tamanegi or mochi like this, and set some rules for robot. For example, students need to wash their hands before touching robot. And at first, there was a dispute over the order to play with robots, but soon the students began to share. Robots were wandering around the classroom, not only during breaks, but also during class. And we also held classes for upper grade students to learn visual programming using robots. We did. And we conducted a survey after this experiment. Improvements were seen emotional and intellectual curiosity like this. And yeah, and please show next slide. Sorry. Yes, teacher the school reported changes in their students emotional and intellectual curiosity. Presented here two of most striking examples. One example is a student who didn't come to school is now actively attending school. The students often got in trouble, but however, when robot came to the classroom, the students showed interest in robot, and through robot, the students were able to talk each other.
Okay, thank you, Megumi. Yeah. So I think that's quite interesting, actually, because I think that shows as well that there are two different ways, maybe that, at least two different ways that robots can be seen as being useful in a classroom. From my perspective, of course, what we're trying to do is educate children, so the children are more, they're more familiar with what the robot is, right? Whereas with Lobot, for example, it's a way of using robots to help children in a more of a social care type of
Yes.
and
exactly.
emotional. Is that right?
Yes.
Yeah.
Some teachers said their students become calmer.
Right. So it's a completely different philosophy for using robots in the classroom, but still obviously has quite a lot of benefit for children, I would say, right? Yeah. Yuki or Hyuki, would you have any input on this?
Yes, thank you very much, Megumi-san. It was very late to listen to the special report from the teachers. Actually, it was amazing because the children become calm and they become more aggressive to join the class. That is very amazing. And before I was thinking maybe if there was a robot in the classroom, makes kids feel kind of, how do you say, not how do you say, warm or something, a little bit cold or cool or something like that. That was my image. But through the slide, I learned how it works in the classroom as a kind of just like a human being, something like that.
Okay, let me add a few comments. So as Yuki-san mentioned, Dr. Tech itself hasn't started, education using robotics yet. But then, I'm a parent of two daughters, and then actually I'm trying to teach my daughter, for programming. Then the problem was, or more like challenge was like, how to have them focused on programming actually. Programming itself, it can be actually boring maybe, like especially girls maybe, then maybe just possibly, calculating numbers, etc., or maybe, do game programming, maybe interesting, but for I believe for many kids it's not that interesting actually. But then if you use robot or maybe control robot or something, that's I think that's a very good way to use robot and, have them experience actual, programming. So I think that's, one area I'm really interesting. And then it seems like in that graph shows that kind of, thing. Kids interested in the programming using robots. So I think that's a good thing. Yeah.
Absolutely agree. Yes. So Nicholas, you look like you're going.
Yeah, I was going to say, I completely agree with that. The students engage with robotics in a way they don't with other educational subjects. I think it's why it's such a useful tool for getting people, thinking about these fields in a way they wouldn't have before. They sort of treat it more like, like a game or an excursion or something like that, rather than a class they have to commit. And I've seen this quite a bit where we go to underprivileged schools and stuff like that, where they aren't really engaged in the class too much, but they get really involved in the robotics really quickly. And it just grabs their attention so fast, and can be a really great gateway to help expand their educational horizons, I think.
So just slightly outside of the question, sorry, Michael, but just to ask, because it's an interesting subject, why do you think that might be? What is it about the physical robot that makes children feel more engaged with the subject?
I think the coolness factor just comes into a little bit there, especially comes down to what you're trying to do with it. So, one of the common ones we'll do is like a sumo wrestling competition, and that gets them really excited quite quickly. And I think also, it's a way to help awaken the hidden engineer in them. I think anyone who's worked in the engineering field has had that click moment before where like they get a problem solved. And that can be very engaging into itself. And I think this can be a good gateway to do it through there.
Do you agree with this, Megumi? Yeah. Yeah. Okay. Right. I think we need to move to the next question, right? All right. Thank you. Okay. So what advantages are there to using robots in education, and who is most likely to benefit? I feel we slightly answered this question already. But okay, who is most likely to benefit? Any ideas there?
Yeah. I think the benefits are not only for children. Improved classroom relationships are also a benefit to the teacher. And some parents reported an increase in topics of conversation at home. And yeah, we can benefit. Everyone can get benefit.
So not just the students, also the teachers. Yeah.
Yeah, we think.
Yeah. Any comment?
Yeah, I think one of the advantages I've seen is I think with a lot of things that we try to teach kids in school, it can be very abstract. There's always that question, why am I learning this? When it comes to robotics, you can more sort of limit the scope down to what specifically they're trying to achieve. You can give them something tangible they can get out the other end of that, which I think gives a focus in ways that other ones can't. Something like game development for programming can be quite useful for that as well, but it can be a little bit of a more complex to get going with that. But yeah, I think robotics is a good way to start that and give them a very clear goal they can work towards. They can see the progress and how they're improving as they go forward.
Yuki or Ryoki?
Yeah, just one comment. Totally agree with what we had now. And just one thing is, this more like in learning robotics itself, or maybe learning technology itself also help, possibly, that, children themselves, and also maybe future of the, society, maybe, for example, means like, I think going forward, society, for example, Japan, lots of discussion going there, population decreasing, aging society, etc. Then you might need more robots, etc. Then robotics education, hopefully grow more, engineers, and then they can develop, robots, and then that may help society in future. I think, maybe for long term, I think that would be the most beneficial, or maybe, I would say that's the dream maybe, or goal, I think, of us. Yeah. I don't know directly answer the question, but yeah.
No, that's fine. I think that's such an interesting point. Yeah, because I was thinking about it in terms of the children or the teachers, but you're saying that the society in general also would benefit from people's understanding of this, right?
Yeah, I think so. Hopefully, the people get. I mean, for example, Japan, engineering itself is not that popular, but same time, very interestingly, Japan has a great, company like, developing robots somehow. To be honest, I don't know why that happening. People saying, yeah, if anyone knows why, Japan has a really great company like Toyota or some other, company develop great robots. At the same time, people telling, engineering education is not great. I mean, not strong area. Somehow it's great. And then if we can start those education from early stage, maybe, we can do more or something. Yeah, yeah.
Yeah, I think just to back that up, like what I've seen with a lot of students, and I've actually met a couple of engineers who said that doing robotics courses and stuff like that is what got them into engineering. And in a lot of cases, they didn't really consider that it's something they could do, that it was an option for them. So if they're coming from an underprivileged background, or if they're, from a group of people who aren't usually considered to be engineers, so women, unfortunately, that's a problem our industry has that we're hoping to fix. But yeah, it can be a way for them to encounter the field in a way they wouldn't have before, and can really awaken something in them and really inspire them to continue to grow that moving forward. I've seen robotics courses as a really good way to introduce them to that field in a way that they can then grow in the future.
Okay, good. Thank you. So do we have the next question? Okay. Have you seen any special reactions from students when interacting with a robot? I think probably Megumi, you have a lot to say about this, right?
Yeah, I will introduce an example that we didn't expect during the demonstration experiment. We thought that having the robot moving around in class might be distracting, but some students told us that when they are tired, they look at the robot and found answer to their tests. Yeah, people come up with better ideas when refreshed than when they remain tense, and robots might be a nice change of pace during the class. Robot would be helpful in the workspace as well in this aspect.
He knew we were talking about him. Yeah. Okay. Yeah. That's really true. Yeah. I see that the kids might see something in him that kind of helps them to feel more comfortable and help them to interact more with the class. Yeah. Have any of you guys also seen something like this before?
Yeah, I mean, I guess going back to students being engaged in the robots, I remember I was doing an event once. We were teaching some young kids how to program a little robot, and we'd set them up, we'd shown them how to flash the robot the first time and everything, and they're sort of just starting to understand, just starting to get it. We take it onto the ground to practice it, because running off the table and breaking the robots is not ideal. And when we're introducing them to the first part of the program, we intentionally put a bug in there. So we put it on the ground, we get it tested, we ask them like, okay, what do you think went wrong here? And one of the students had this like, oh, I got it, picked up the robot, ran away, left me down there on the floor. They've just forgotten the rest of us exists and started getting really engaged with the robot there. So yeah, seeing that click moment with them is always a very interesting experience.
I definitely think children have this sort of innate understanding of connection with the robots often. I suppose it depends on the design of the robot as well, or what the robot does. But yeah, I see that a lot as well in our classrooms. In where we teach, we often use Sphero RVR, the Sphero, which is the sort of spherical rolling bot, right? Yeah, and so kids get a lot of enjoyment, I think, from seeing how the robot will react to interactions such as movement or light and that kind of stuff. It sort of has this kind of eureka moment, I feel, when they see that, they're like, oh wow, it can do that, and children aren't really necessarily exposed to that straight away from a young age. So when they see that for the first time, there's like, oh, they didn't know that could happen, and that really, I think, conjures up some sort of a magical feeling for them a lot of time. Yeah, we get that quite a lot in our classroom. Yeah. Yeah, sorry, Nicholas, go.
Oh yeah, I think when they're learning as well, you can get some very interesting solutions to problems while they're still figuring out the tools. So we had one student recently who submitted code that had, I think it was 25 nested while loops for their sequential logic. Just like breaking out of each one to move across the program. And yeah, it's really interesting to see the strange but amazing ways they get to solve the problems while they're still learning things.
Yeah, any other comments here? Yuki? No? Okay, all right. Okay, so next question then. All right. Okay, so we've got, how do parents and teachers react to the use of robots in the classroom? So, anyone want to take a hit on this?
Yeah, I suppose I can maybe jump in quickly on that one. Yeah, I think normally I found when robots are introduced in the classroom, it's by a passionate teacher or a passionate educator who believes in that technology and wants to use it to its fullest. Where you can sometimes have some trouble, though, is that maintaining that across the years and across the classes can be quite tricky. It's one of the challenges with developing educational robots, I think, is getting the balance between something that is flexible enough that you can really, use it to its fullest, but also has a low enough barrier to entry that it can be picked up by any educator who's interested in it. I think, back in Australia when I was in school, pretty much every school ended up with a Lego Mindstorm kit that in a couple of years just ended up in the cupboard because there wasn't that teacher who wanted to, keep driving it forward. And so, yeah, I think it can be used, it can be driven by passionate educators as well. But I think having it more introduced into the central curriculum can also be quite helpful there, and something that's more normalized rather than as a sort of special case, special event.
I do have a comment about that, actually. I'm wondering what you think. Since we're actively involved in obviously educating the youngest generation right now in the use of robotics, and I believe that that's become more common more and more over the last 10 20 years probably, right? Would you see that in the future perhaps that kind of problem that you mentioned would be less of a problem because more people have grown up with robots in the classroom?
Yeah, I think for sure. I think most students at this point have some, experience programming, for example. And yeah, robotics can be a good something that they're going to be more familiar with moving forward as well. I think what I see a lot of is a lot of the robots that students have access to outside of school settings are more like toy, for lack of a better word. They don't have that same expandability built into them there. But that being said, more and more are starting to open up to the idea of kids programming their own robots and adding their own stuff into there. So things like the Scratch programming language has been a real godsend in that area. And so, yeah, I think as they're getting more and more familiar with it, we'll see this become more normalized. I know in Australia, they've recently introduced, programming as a core curriculum subject. I think a lot of them are using robotics in that sense. And I think that mechanism can be how we can get more of this into schools.
Thank you. And Yuki and Hiroyuki, again, of course, you may be involved more closely in this industry. So have you ever seen any reactions like this from teachers or parents to the robots you use?
Actually, I haven't.
No, okay.
Yeah, sorry. But I have a question. So, okay.
Yeah. Our question is like, kind of gender difference. For example, boys and girls, have some any difference, like, how to engage on, the class using robots.
Yeah, so I think, back when I was doing these events in Australia, there was still the stigma that it's the boys who want to do this kind of stuff. But in practice, that's just not true. I tend to find all the students get engaged at the same kind of level. I remember an event once where we had like an open booth and kids were coming through with their parents and doing stuff. And there was a parent who came through with a little girl and a little boy. And the dad was really interested in getting the boy to do the programming, even though he had kind of no interest in it, even though the girl was really interested in doing it. So thankfully, we still had a chance to get that girl set up with one of the robots and start getting into it themselves. And yeah, these social pressures can be a big problem. But I think robotics can be a good way to help show people that, yes, you can do this. And this isn't, something that's closed off to you. And yeah, once you can show them that they can do it, if they've got the passion for it, they'll find their way into it themselves. and obviously we can provide additional support in that area. But yeah, that inspiration, I think, is what can help close that gap a bit, and yeah, help hopefully get rid of that stigma.
Sounds great. Thank you. Thank you for the answer. I think, the one of issue is, for example, if you work for some engineering company or something, then, you see gender difference. For example, there are lots of, male engineers and then really less female engineers. And then I think I guess we have to change that. And then, yeah, Dr. Tech also interested in that area as well, like, how to educate female students, like, yeah, to learn engineering, naturally or smoothly without feeling some kind of, I don't know, some pressure from, like, society or something. But it sounds like, not much, pressure. I don't know. But, yeah.
Well, yeah, I think there's expectation that it's not a field for them in society in general. Again, thankfully, we're starting to get rid of that, but that's still a pervasive thing. But one of the things that I think is really unique about the engineering field is that it's a field that people are passionate about. So if you can awake that passion, you can drive people into that industry. And yeah, I think that's sort of where the key needs to be. Obviously, there's a lot of other hurdles that need to be overcome, but once you have people who want to do it, like, the women will break through into this space. Like I think in America and Australia as well, we've reached the point where university graduations, more women are graduating university than men. So it's starting to come through the pipe. I think Japan is at least a couple of years behind in this respect. I've definitely noticed there's a lot less women in the field here than there is in some other countries. That is changing, thankfully. And yeah, hopefully we can continue to do that. But yeah, continuing to support those groups and continuing to make those opportunities available to everyone, I think, is a big way to help improve that area.
Cool. Thank you.
Yeah, I totally agree. I think this is a really, really important subject. I think I heard you say, Nicholas, that you were involved in a group called Robotics, right? Yeah, it's quite interesting because I also did the same group about 15 years ago in the UK. So I was like, oh, really? Oh, I remember doing that. Yeah, we used Lego Mindstorms at the time. Yeah, but it is very interesting that when you actually introduce the platforms to the children, there isn't really a difference in the way that they interact with it in the end, right? It's more just the social norms, isn't it, that dictate what the parents think or what the educators think. What do you think?
Yeah, absolutely. And when we usually do these kind of workshops, I tend to find that, like I said, those expectations are there at the start, right? There's the guys who are interested in, and there's sort of sometimes the pressure from the teachers around that as well. But once you get all the students with hands on this equipment, very quickly that just boils away. And yeah, RoboGirls is a great organization doing that that kind of work across the world. For anyone who don't know, they're a robotics group that goes out to high schools with a specific focus on getting more women involved in engineering. And again, using robotics is the way to do that, and Lego Mindstorms all over the place. They don't just teach female students, of course, but that's the main goal, their main focus there. And yeah, I've seen it work really well. I've definitely seen, you can see students who really never consider this as a possibility for them. And then after a workshop like this, understand, hey, I can actually do this. And this is something that's fun, that I'm interested in. And so that's one of the reasons why, the chapter that I worked for focused on students who are in year 9 and 10 before they picked their specialization subject before university, to really help them understand that, yeah, you can do this. This is an option for you, and it's something you might be interested in. Let's give it a try, and then you can build it out from there. And I've met several engineers, usually women, who have said, yeah, they didn't think about this as a possible field for them, but then after engaging with a group like RoboGirls or other events like that, sort of had their eyes open to, hey, I can do this, and then opened up a whole new new career path for them.
Yeah, just quickly, Megumi-san, I wanted to also ask you, have you ever seen any sort of change in behavior between boys and girls when they interact with Tamanegi-chan?
Tamanegi is their own name. Our product name is Robot.
Sorry.
Robot, yeah, sorry. It's confusing. Yeah, actually, girl living with a robot say, my dream is a programmer.
Okay.
I saw many times.
Oh, that's incredible.
Yes, yes, develop robot can develop sorry, attachment to science subject, I think.
Okay. Yeah. Okay. Thank you very much. Do we still have time or two more questions? All right. So next here is, okay, are there any negative points to using robots or other advanced tech for educational purposes?
Okay, maybe I can quickly jump in with that one. So I think when you're trying to pick a specific type of robot to use for education, one of the big challenges is going with something that's easy to pick up, but also has the flexibility to, go beyond a one-day session, and that kind of thing there. And that, easy to start, hard to master kind of thing is quite tricky, especially because a lot of the commercially available robots you can just like get off the shelf are more meant to be like toys that you take home and play with a couple of times and then not again. So really getting a robot that you can continue to use moving forward and that you can use to teach some more advanced robotic subjects, so like AI and other fields like that, can be a bit of a challenge. And I think, again, that can come down to the educators at the school and what they're intending to push and how they want to do it there. But yeah, also, as people supporting them, we can give them the resources to help with that. Things like lesson plans or even competitions can be a really good way to help encourage schools and students to continue to engage with this moving forward. And yeah, I think that's an area that can be tricky, but one hopefully we can solve as well.
I do agree with that. Yeah. From my experience, again, I think that one of the big challenges for teachers is that we have to be quite careful about the platforms that we're choosing to use. Quite a lot of them, I mean, there are a lot of options out there now, right? But for some reason, I feel like it's still kind of a growing trend that not every school has an established robotics curriculum yet, right? And we're the kind of thing we do is getting more and more popular still, but it's not standardized. So one of the issues is that a lot of the robots that are out there do not actually have very good support or, as you said, long-term progression. And that kind of thing needs to be established by the teacher quite carefully before they select what platforms they're going to be going forward with. So I think that's a bit of a challenge for educators myself. Yeah. Yeah. Any other comments on this?
Yeah, I just wanted to add a few comments about that. Totally agree with that. And then we are also researching what educational material can be used for the robotics education. Then we encountered more like for example, there's a toy maker or something developing the product, and then they do also provide education, but it's more like a part of marketing or activity or something like that. Then if you start using that, maybe it kind of locked to that platform itself. So hopefully there's a more like open source type of stuff in robotics as well, and maybe available, but that case may be too flexible or something, then may be difficult to use for education. That's one of the challenge we are facing now, and then not easy to find a good answer, to be honest. Yeah.
Yeah, I tend to find a lot of the robots have very good support for the first month of curriculum about that. And then if you want to take it beyond that, you have to invest a lot more work. So I know a couple of robots where you can bolt Raspberry Pis to them. And obviously, once you can do that, you can do a ton with them, right? I've seen students do projects where they've got multiple Raspberry Pis and cameras set up observing a fake warehouse, and they can move vehicles around, that kind of thing. But to build that curriculum is something that's a challenge for educators. Because they have to know this stuff first, and putting together something that is, challenging but achievable for students is quite difficult. And yeah, there's still that gap in place of it there. I think there is starting to be some standardization coming down the pipe, which is nice. So again, Scratch is a good example of this. For anyone who doesn't know, it's a block-based programming language. But they're still not fully standardized. So a lot of different products I've seen tie that to a different backend programming language. So whether that's JavaScript or C# or something like that, or Python. And yeah, there's still a lot of customization per platform. So it can be difficult, especially if those organizations aren't focused on using those robots for educational purposes rather than as a more commercial kind of thing.
I think many times actually you can sort of tell how good the product will be for your educational curriculum based on, like, for example, the community. Like often, you know, the very well established ones will have a very large user base, so they'll have lots of material available through the community, that kind of thing. But yeah, there isn't a standard yet, unfortunately, I don't think, within education. But yeah, maybe we'll see that going forward. Anyway, I think we have one more question. Yeah. Oh, audience Q&A. Okay, let's go.
Okay, thank you. Thank you, everyone. So we're going to do audience Q&A. We have people online, potentially no questions came through on there, but we can take QA from the audience here if anybody has a question. Yes, please. Or if you just want to tell me the question, I could tell them.
Yeah, I'll say it. I'm David. My question is, so there are a lot of robotics platforms that I'm familiar with that are quite expensive and can be a bit of a hurdle for lower income schools, lower income individuals. My question is, how do we even that playing field so that money is not as big of an issue for some of these students?
Yeah, maybe I can jump in quickly with that one. So I think that definitely can be a big problem. And the cheapest robots tend to be the mass-produced ones, which aren't necessarily great for education as much as they are, as I said before, like toys, even though they can be used for that as well. There's a bit of a challenge here where you're talking about volume of product, right? So like the probably biggest one that used is the Lego Mindstorm kits, but those are very expensive. And then other ones that are more focused on the educational space tend to be limited run, which means they're quite a bit more expensive as well, even if they're offering, you know, less kind of features. One area that I've seen that's been really helpful in that space is the adoption of simulation. So I've started to see a few of the manufacturers either officially or unofficially support simulated environments. So that can be useful if you want to give every student access to their own robot. So normally when you're doing like a workshop or something like that, you'll have a team of 3 or 4 students per robot. And like for the Battle Quest competition, we have all the teams for the finals have their own robot. But for the preliminaries, when we had a much larger pool of students, we gave them a simulation instead. So I think that can be an area where it can be a nice lowering for the barrier of entry, especially if you want them to be able to like have each of the students take something home they can work with and then come into the school and then work on the actual robot itself. So the integration of simulation, I think, can be very beneficial then.
Great. Yep. If nobody else, we can move on to the next question. We currently have a question from online from NT. And I think this question is really geared towards, I think, Dr. Tech and then also Avi. So startups and businesses have a hard time entering the school market, especially public schools. So what is happening at the systems level to encourage more programming programs like programming Dr. Tech, coding, Tokyo Coding Club? What is happening at the level to encourage more of these programs to enter schools and formal environments? This person finds a gap between mixed course of study and what is actually happening in schools. So this person also mentions there are many limitations with GIGA. I'm not sure what GIGA is though. GIGA. If you can expand on that, that'd be great. If not, I'd love to get your thoughts on, I believe it's what is basically being done to help these programs enter schools and something that may be at odds with like the official curriculum from MEXT. Yes.
Can I speak in Japanese? It's too difficult to explain in English.
No problem. Go.
And he
please.
will cheat.
Okay, sure. No problem.
公立の小学校に私も何度かお伺いして、プログラミングだったり、ファイナンシャルリテラシーのオンライン教材を提供させていただきたいとお話をしたんですけれども、一番最初に言われることは、先生方がまずついていけません。忙しいですっていうことをまず言われます。これが最初の一つで言われます。もうそこでシャットダウンされるんですが、そもそも根本的にどうしてそういうお断りの言葉が出てくるかというと、あくまでもそれはお断りの文句であって、本来、なんて言うんでしょう、根深いところにあるのは、学習指導要領といって、The New Courses of Study という日本の政府が定めている、この文科省が。それに従って学校は授業を、時間割を完全に決めなければいけないというのがあって、じゃあ、プログラミングは、ロボティクスの授業は、どの授業の中で入りますか？何時間できますか？1週間にロボティクスの授業は何分できますかっていうきめ細かいところまでを我々がサポートしなければ導入しづらいという、まずすごく大きなハードルがあります。で、学習指導要領というのを2020年に、政府の方が少しずつ変えていきましょうということで発表はあってますし、今多分取り組まれてるんですが、おそらくこれは10年ぐらいかかりますので、2030年ぐらいに次の学習指導要領新しいのが出てくるんですが、その時にじゃあ世界はどうなってるかっていうと、もう、なんて言うんでしょう、私たちが想像ができないくらいの世界になっている。となると、今、学習指導要領は2040年、50年先、50年というところを見定めて作らなければいけない。それ、2050年のその社会を見据えて、子どもたちの学習指導要領を作れるのかというと、そこが今一番大きな問題になっているので、ちょっとこの質問のお答えになっているかわからないんですが、そこを民間の企業と学校とがしっかり対話をしながら進めていかなければ、このギャップというところはなかなか埋まるのが難しいのかなっていうのが、私たちが今日頃考えているところです。
Let me try to translate. Sorry, it's actually longer answer than expected, but I've had that before, so I try to answer. So basically, we are trying to upload, Japanese public school to, provide our educational, mainly, programming educational program. And then first, what we are told is basically, the teachers are too busy and then couldn't have time to handle, to new subject. When we do, when we teach, they don't have a time to teach as well. So that kind of, first resource issue, or more like, teacher does, kind of afraid about the subject. But then actually, what we feel is it's not that truth, actually more like excuse. The actual issue is that new courses of study is defined by government actually. So those Ministry of Education decide that course already, and then this subject itself doesn't match to that course. So that basic idea is they don't know how to put that program to their entire education program. So that we have to help everything like, okay, this is how many times you need a class or that kind of detail we have to provide. Otherwise, they couldn't, school couldn't take it. That's the basic thing. And also, same time, for example, they start talking about 2050, 2025. Yeah, they start talking about new generation of course of study itself. But then that's actually a little bit far away, like 2050, which is a bit far away actually. Then even like in 5 years future, we don't know much in what's gonna happen. Chat GPT comes in and then etc. So then then they have to decide 2050. Then that's a bit too challenging, and then that's also another issue. So we, that's that answer.
Great. Thank you very much. So we're actually approaching the end of our time. So if you had any quick wrap up related to that, 1 minute, if you want to give something.
Subject's a little bit out of my scope of knowledge, so I would defer to the experts.
That's fine. This was really great. Thank you, NT, for your really wonderful question online. I also wanted to let the audience know. People online, please come to the next event if you can. People here, I'm sorry that we don't have more time for Q&A, but the panelists will be around doing meetup, socializing, networking. Let me get over here. Until I believe 8 or 9 p.m. So I'd like to give our panelists a big round of applause. Thank you very much, everyone, for coming out. Thank you. And also, please come see Tamanegi. Yeah, he went to sleep. So, so, wakarimashita. Okay, thank you very much. See you.
はい、ありがとうございました。これにて本セッション終了となります。次のセッションは6時から現場の準備ができ次第、新しい当たり前を作り、女性が働きやすい社会を作るにはのセッションを始めてまいります。オンラインでご参加の皆さん、今しばらくお待ちください。